So picking up where we left off, we're kind of switching from trinomials now, so meaning like 3 terms, trinomials, to just polynomials, meaning that there's 4 or more terms. Now, we've been factoring by grouping, and what's nice about polynomials is that we're going to continue factor by grouping. Factor by grouping meaning that you just group it and then you factor out what you can. So if we take a look at this, I don't need to split my middle term into 2 terms because it's already 2 different terms. So I'm just going to go straight into grouping. So I'm going to look at the first half and then I'm going to look at the second half, okay? What can you factor out of the first half? If you have x cubed plus 7x squared, you can factor out an x squared and that will leave you with x plus 7. Now, what can you factor out of the other half? Negative 9 would leave you with x plus 7. So one of your factors is x squared minus 9, and your other factor is x plus 7. Now, sometimes we'll stop here, but this one can be factored more because of this right here. This is called a difference of squares. Difference of squares means the difference subtract, and I have 2 perfect squares. And the way that these are going to factor is that you're going to square root each part. So the square root of x squared is just x, and the square root of 9 is 3, but technically plus or minus. So that's going to factor to x plus 3 times x minus 3 with my other factor of x plus 7. And that's that polynomial in factored form. Now, we'll look more at difference of squares in just a minute, but just know that if you have 2 perfect squares with a minus between them, that's going to be a difference of squares. Now, taking a look at this next one, I have 4 terms. If it's in standard form, then you're good to just go ahead and group it and go from there. So I'm going to go ahead and start grouping. What can you factor out of the first half? If you have 5x cubed plus 25x squared, I can factor out 5x squared. And that leaves you with x plus 5. And out of the second half, 3 and 15 have a 3 in common. And if I factor that out, I'm left with x plus 5. So one of my factors is 5x squared plus 3, trying to line up those leading coefficients. And my other factor is x plus 5. This isn't a difference of squares, so I'm done. That's it. Taking a look at this one, I have negative 20x squared plus 3x plus 12x cubed minus 5. Now, hopefully you catch it before you start trying to group it, but this starts with x squared, and then I have 12x cubed over here. So I'm going to start by rearranging this first. Putting it in standard form would be 12x cubed minus 20x squared plus 3x minus 5. And now I'm going to go ahead and factor by grouping. So 12x cubed and 20x have 4x squared in common. If you factored out a 2, let's just say you did on accident, and then you had 6x cubed left over minus 10x squared, you would see like 6 and 10 x's, like there's still more there. So that kind of tells you to keep going. So I'm going to factor out 4x squared. That leaves me with 3x minus 5. And then over here I have 3x minus 5. Now, this isn't it. Remember that this goes to everything and that this also went to everything. So you're factoring out or you're undistributing a 1 as a placeholder. You still had an additional 3x minus 5 in there. So if you put nothing there, you're like saying there was none, 0 when it was technically there. So one of our factors is going to be 4x squared plus 1. And our other factor is going to be 3x minus 5. Now, before you go, oh, Ms. Bauer, isn't that a difference of squares right here? This is a perfect square, and 1 is a perfect square, but it's not a difference of perfect squares, meaning that once you're here, you are done. So taking a look at the next one, if you want to pause the video and then see if you could try it on your own, go for it. Now, it's always worth looking like, is there a number that goes into 6 and 16 and 21 and 56? No. But if this had been 22, they would have all been even. You could have factored out a 2. So it's always worth double checking, especially when you have multiple numbers in the mix. Okay, nothing can be factored out, so you can just jump on in with your grouping. In the first half, you can factor out a 2x squared, and that will leave you with 3x minus 8. And then in the second half, I can factor out a 7. Remember that 21 divided by 7 is 3x, and then 7 goes into 56 8 times, so 3x minus 8. So one of my factors is 2x squared plus 7, and my other factor is 3x minus 8. That's it. Now, let's talk about some special cases and how I knew that that was a difference of squares. So there's two special cases, and that's difference of squares and perfect squared trinomials, okay? I knew that the difference of squares was the difference of squares because I had a perfect squared, so I'm going to say a squared, and I had b squared, and then it was a difference, meaning that I subtracted them. And if you have two perfect squares like that, then essentially it's just going to factor to be a plus b times a minus b. Square root each term, and then you're going to have a plus and a minus. Now, the other special case isn't if you had a plus b times a minus b. That makes your middle term kind of cancel out. It's if you had a plus b squared. Now, I'm going to make this up and you don't have to write this down. If you had 2x minus 7 squared, that's not 4x squared minus 49. That's not 4x squared plus 49. 2x minus 7 squared is 2x minus 7 times 2x minus 7. So 2x times 2x is 4x squared. 2x times negative 7 is negative 14x. Then I see that again because I have negative 7 times 2x, which is negative 14x. So this doubles up. And the negative 7 and negative 7 makes that positive 49. Okay? And that's what you get when you have a perfect square trinomial. Your first term and your last term will be perfect squares. And that middle term will be kind of double what you get when you multiply those together. So for a perfect square trinomial, you'll see it in the form of a squared, could be a plus, could be a minus, 2ab plus b squared. And that will factor to a, could be plus or minus b squared. In this case, the middle term would have been negative, so that's why I have the negative that's there, okay? Now, to check if it's one of these, difference of squares is pretty easy to check. For a perfect square trinomial, you want to square root each term and then check does your middle term match what it's supposed to. So right here, I see that my first term is a perfect square. So if I square root 4y squared, I get 2y. If I square root 25, I get 5. If I multiply them, I get 10y. And my middle term was 2 of those, so 10y times 2 is 20y. And look, I had 20y. So this is a perfect square trinomial, or a PST for short. Not a PSL, even though I love those, okay? So now that I know it's a perfect square trinomial, what it's going to factor to is the square root and the square root, and my middle symbol is a plus. So this is just going to be 2y plus 5 squared. You could write 2y plus 5 times 2y plus 5. That's what it is, but like you don't have to do all of that. You could just say squared because that means times itself. And that's it, okay? So let's take a look at this one over here. This is not a perfect square trinomial, but if you know your perfect squares, then you'll catch that this is a perfect square, this is a perfect square with a minus in between. So this is a difference of squares. The square root of x squared is x. The square root of 225 is 15. So for our difference of squares, it's going to be x plus 15 times x minus 15. Now, it's important to note in these special cases that factoring by grouping will still work. It's just going to take you longer to get there. So back over here, let's say you chose to do factor by grouping, okay? You would set up your x, sum to 20. Product would be 100, okay? And then you would go through the whole factor process, and it would just take a little bit of time, okay? Over here, this would be a sum to no middle term, so 0, and your product would be negative 225, so you get negative 15 and positive 15, you're still going to come out to the same thing, but if you catch that they're a perfect square trinomial, or like this one, a difference of squares, it's just going to save you the time and the energy instead of factoring the whole thing. So if I take a look at this one, 64n squared minus 169. If you know your perfect squares and you know that that is a perfect square and that's a perfect square. So square root each one. I had a minus in between, so there's my difference part, right? The square root of 64n squared would be 8n, and the square root of 169 is 13. So this is going to factor to 8n plus 13 times 8n minus 13. That's it. Okay. Taking a look over here, my first term and my last term are perfect squares. So let's check if this is a perfect square trinomial, okay? Difference of squares are easy to check. These ones require a little bit more work. So if I square root 49y squared, I get 7y. If I square root 1, I get 1. Remember that it should be that multiplied in double. So 7y times 1 is going to be 7y. 7y doubled times 2 should be 14y, which means that I should have 14y in the middle. So back up here. Your middle term is like the first square root of the first square last times 2. So I square rooted the first square root of the last times 2 is 14y. That's not 14y, which means this is not a perfect square trinomial. So this would be prime. I don't even have to set up my x. It's not going to factor. So taking a look at another one to check, once again, I see a perfect square, I see a perfect square. Square root each piece, so that would be x, that would be 10. Multiply it by themselves, so that would be 10x times 2 is 20x, which is what I have in the middle. Now it is a minus, but all that that's going to do back up here, remember, if this is a minus, then that just means that's going to be a minus. So this is a perfect square trinomial. So this is going to be not x plus 10, but x minus 10, parentheses, squared. And then taking a look at this one, if you know your perfect squares, then you'll know that those are both perfect squares. Okay, and these are the ones that you have to be a little bit careful on. If you square root each piece, you get 4x and you get 14, which means that this has a GCF or another factor, or GCF greatest common factor, that you should factor out before you do your difference of squares. Okay, if you have this, like you square rooted it, right? If you can kind of keep going, it means you messed up somewhere along the way. So let's back up. Is there a number that goes into 16 and 196? If you take out a 2, you're left with even numbers again. So see if you can take out a 4. So if you factor out a 4, I'm left with 4x squared, and 196 divided by 4 is 49. It still is a difference of squares. So now you can square root and square root. So that would be 2x and that would be 7. So 2x plus 7 times 2x minus 7. But don't forget your first factor of 4. Now, factoring is one method of solving. So if this says factor and solve, there's just a couple things that I'm going to do extra to make sure that I can solve this. Okay, first is whenever you factor, it needs to equal 0, which it does. So now that I've checked that, you can go ahead and set up your x and factor like what we had above. So sum to b, or negative 7. Product is a times c, or 1 times 6 is 6. So think for a minute. What would add to give you negative 7 but multiply to give you positive 6? Well, negative 6 and negative 1. So now I'm going to factor by grouping, remembering that it equals 0. So x squared minus 6x minus 1x, or x plus 6 equals 0. Factor by grouping. Okay, hopefully by now you're kind of getting faster at this and it's coming back to you. Factor out an x, you're left with x minus 6. Over here, factor out a negative 1 to change the sign. You're left with x minus 6 equals 0. So one of your factors is x minus 1. Your other factor is x minus 6 equals 0. And then maybe you're not, maybe you remember from here, you said each piece equal to 0. And you solve, so you get that x equals 1 or 6. And that's what we're going to get into, is how do you solve by factoring. But in order for you to solve by factoring, you have to know how to factor. Okay? Good luck on your assignment.